Hello. All right, so we're going to get back going on example 2. Find the z-score that corresponds to each percentile. So in order to do that, you have to change your percentile to a proportion, and then your proportion changes to a z-score. Okay? So it's percentile to a proportion to a z-score. Okay, and you can also go the other way. Z-score to a proportion to a percentile. Okay? All right, so we know that this is a percentile. We need to divide it, change it to a percentage. Okay? So we know that this is a percentile because of the TH. Okay? We need to change it to a proportion. Okay? And then once we get it to proportion, we need to go to the z-score. Okay? So in order to do that, we need to find where is 0.05 inside the chart. Okay, so 0.05. 0.05. 0.05. Okay, so find the pattern. So you can say that these z-scores are going down, 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 down. Okay, here we go. Down, 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 right? So they're going down as you go to the right. And so we've got a difference of 0.0505. Okay, so we've got these two here. Put my finger right between them. Okay, so 0.0505. Or we've got 0.0495. Now some of you, if you want, you can find the difference between the choice and the actual number. What's the difference in your head? But if you don't, do your subtraction on your calculator, which I'm going to do because not everybody does it in their head. 0.05 minus 0.0505 equals, and then negative 5 times 10 to the negative 4. The negative 4 as an exponent moves your decimal left to the four places. So there's where it starts, and then 4 places. 1, 2, 3, 4 decimal, and then in the waves put zeros as placeholder. So it's negative 0.0005. Okay, so how far apart is the original number to the actual number in the chart? You're always going to have to, well, not always, but most likely going to have to find one that's the closest, right? So you take your original question, 0.05, minus 0.0495. And that's the same number, only it's positive, right? So 5 times 10 to the negative 4. Negative 4 means the decimal that's after the 5 moves 4 places to the left because it's negative as an exponent. So 5 is here, 4 places to the left. 1, 2, 3, 4. Fill all the other waves with zeros, and then 0 to the left of the decimal. Okay, these are the same. Same, so either number is acceptable. Okay, so I'm going to choose this one if we don't care, right? Because it's the same difference, right? And then so when I get that number, there it is, I have to move up to 0.04. So 0.04 and then I have to move across negative 1.6. So if this number in the column is put together with this number in the heading, okay, they both have to be the same sign. So that's understood to be a negative. So you say, therefore, the z value is negative 1.6 plus negative 0.04. If you want to type that in, you'll get z is equal to negative 1.64. Okay, and that's what your question is asking, is what is the z value? All right? Okay. So again, if these questions don't make any sense, these are the kinds of questions you're going to rewind the video for, to listen to again. You could type this question into your Google search engine to see if there's any teaching videos in addition to the one that you're listening to, and or you could ask these questions to be gone over during our Google Meet session. All right. Given that people read an average of 35 books in their lifetime, I feel like my question A is gone. Where is my question A? Okay, it is. 35 books in their lifetime, and the standard deviation is 5. Five books. Answer the following questions. I'll have to make sure that you've got your handout that has this part of the question there. I don't know what happened. Okay, so A question is, what proportion of the population reads 12 books in their lifetime? Okay, so well, what's been given? Let's do a thought process here. So we're going to use the method called guess. So G is what's been given. Okay, so what's been given? We have an average of 35 books. So the average is 35 books. We've been given a standard deviation, so we know that's the symbol of standard deviation. So standard deviation of 5 books. Are we given anything else? No. So GU, okay, so U is unknown. What are they asking us for? Oh, move this over. They are asking us for what proportion of the population reads 12 books, okay? So what proportion? I don't really need to write of the population, okay? We understand that a proportion is always of the population. So what proportion reads 12 books? Okay, so what proportion is what we're finding? Okay, so GUE, E is the equation. So we're using the acronym GUESS. Okay, so the equation, what do we have as our equation? What page? So we had on 3.5 to begin, okay, we had this kind of thing, right? All right, now, what I have to know is to find a proportion, I need a Z value, okay? So since proportion needs a Z value, okay, I need a Z value, therefore, this really, right, knowing which one to use, I have to connect the word proportion to a Z value. Those interact with each other, okay? So, for example, the Z values are here, okay? Those are where the Z values are. This here are proportions, right? Okay, so if I need a proportion, I need to find a Z value. If I need a number from here, I have to first have a number out here, okay? So therefore, I need a Z value, and we already said the Z value is this formula here. Oops. that formula there. Okay, so I just copy. So I'm going to use, therefore use, z is equal to x minus x mean, all divided by the standard deviation. I'm going to try to find a different piece of paper. Okay, so I'm going to keep going on A. Okay, so A continued. Okay, so if we're going to use this formula, after I spell guess with G-U-E, the next one is S, okay? S is the solution, okay? I'm going to use the equation. I'm going to use Z is equal to X minus the mean divided by the standard deviation, and I'm going to sub all of the values that I've been given, okay? I've been given a mean of 35 books. I've been given a standard deviation of 5 books. What else? Okay, what proportion reads 12 books? That is my individual score. It's my data point, okay? So my individual score, or my data point, is 12 books. So what proportion, okay? So the reason you know it's a data point is because it's directly influencing the proportion. So what percent is represented by 12 books, given the standard deviation and the mean, okay? So I'm going to sub those in. So Z is equal to X, where X is 12, minus the mean of 35, all divided by the standard deviation of 5. Do your numerator first. So 12 minus 35 is negative 23, divided by 5, negative 4.6. Okay, now the Z value of negative 4.6, if you remember what we were saying, there is no Z value of negative 4.6. Why? Because the highest number is negative 2.9, right? Can you see that? Okay, the highest number is negative 2.9. Highest as in most negative, right? So since no Z value is larger or is more negative than negative 2.9, we can say that zero proportion of the population read 12 books in their lifetime. Okay, it's so far away. Oops. It's so far away from the mean of 35, I think. Okay, and this is 1 standard deviation, and this is positive 1 standard deviation, and that's a difference of 5. So that would be 30, that would be 40. 12 books is way over here, okay? 12 books. That's outside the 0% to 100%, okay? So that's way, way over here, 12 books. It's an outlier. All right? Okay, let's see what the next one said. What proportion of the population read 40 books in their lifetime? Okay, so we would, again, Okay, so here, S is the solution, and the last S in the guess is our sentence, which we've been able to say is this. That's our sentence, okay? Since no Z value is more negative than negative 2.9, we can say that 0% of the population read 12 books in their lifetime. It's an outlier, okay? Alrighty. So G. G is for the start of guess, so what's been given. So we have 40 books, so we have given. So we still have the mean of 35 books. And we have a standard deviation of 5 books. And that alarm tells me that I have to stop because I'm going to run out of video space, but I'll come back.